Hi, welcome to the second tutorial of the Machine Tool Flow Creator tutorial series. My name is Fabian and today I will show you what low frequency data is and how you can use it on the SINUMERIK. Therefore, we will program a small application which is capable of monitoring the program status and setting a user alert according to that. You will learn how to read data from the SINUMERIK manually, how to work with data subscriptions where you receive a variable change, and how to write data on the SINUMERIK. Before that, let's talk about what low frequency data even means. Low frequency data is the term for the non-deterministic and non-synchronous communication. The efficiency depends on the control utilization, and the data access is done via the BTSS interface, the S7 protocol, Focus2 or OPC-UA. Low-frequency data can either be accessed by single or multi-parameter reading operations. The term SINUMERIK low-frequency data means the data access via BTSS, so reading or writing operations. The operations can either be polling or data subscriptions. A data subscription means that you subscribe to a variable, and whenever that variable changes, you get a notification with a new value. Data that can be accessed is either PLC data, system variables from ANSI, or static NCK data and GOD variables. Let's talk about how the Edge receives data from the SINUMERIK. The Edge uses the NCK HMI interface, just like any other HMI application, and it acts as a client to receive data from the NC. You can see different ways of addressing variables, for example BTSS variables, PLC variables, or GOD variables. When working with subscriptions, it is necessary to talk about how the Edge internal communication channel called Databus works. The Databus acts like an MQTT broker, so it handles messages between different applications. We have, on the one hand, applications called provider applications, which send data to the Databus. This data can, for example, be SINUMERIK high-frequency data. Then we have consumer applications, so they get a notification with the data whenever the provider application provides new information. The same thing goes for the SINUMERIK low-frequency data events. So whenever a variable from the NC changes, we get a notification from the SINUMERIK adapter, and the Databus provides that notification to all the applications which subscribe to that topic. So let's get started. First of all, we create a new flow. We do that by clicking on the hamburger menu, go to Flows and click on Add. Alternatively, we can use the plus sign to add a new flow. Let's change the name. The flow is called Tutorial 2 and we give the name SINUMERIK low frequency data. After we did that, we can start by inserting an inject node. An inject node is normally used to start the flow. Then we can use the parameter service reader node. This is used for polling operations to read variables. We connect both of them, and then we need some nodes to convert the output, and we can copy them from the sample flow which is already available in the flow creator. We copy these 3 nodes and insert them in the tutorial flow. And there we can see the output typecast and 2 debug nodes to show the parameter service error message and return code. After that, we insert another debug node to show the results of the reading operation, and we connect it to the output of the parameter service typecast. Now the next step is to create the input for the parameter service.
We do that by clicking on the inject node and select JSON as the format, and then we can copy the required input format from the documentation of the parameter service reader node. And we can simply add or remove variables. The first variable is a BTSS variable, the second one is a PLC variable, and the third one is the GOD variable. And please make sure, if you do this along with me, that you only declare this variable if it's available on the MCU side. Otherwise you will run into an error. Then we click Done, and now we can deploy the first flow and check if the reading operation is working. And now you can see that we got the results of the variables and are displayed on the Debug tab. Now I want to show you where you can find the GOD variables in the SINUMERIK Operate. For that, make sure to switch to the Operate and navigate to the Parameter tab. And then you can go to User Variable, and on the right hand side you will see the global GOD variables. These variables are normally declared in a definition file. For more information, please make sure to check the documentation which is linked below. Now we know how to read variables, let's check how to write variables and how to work with variable subscriptions. Therefore, we open the MindSphere and go to the App Management, and there we search the current asset and we navigate to the Machine Tool Flow Creator app to open the configuration. In the configuration we can control the access rights, which variables can be written, and also we can handle the data subscriptions. First, let's see where we can change the access rights for writing operations. We add a new variable, and this variable is the PLC variable, which is used to control user alerts. And in our example we use the DB2, and there the user alert, which is controlled by the DBX 180.85.4. And after we did that, we can add the low frequency data subscription in the subscription service tab, and there we can copy the subscription from the documentation, and we only change the message name and the data point name to the program status variable in order to receive a notification whenever this variable changes. So let's check if the format is right, and now we save the job and we can check the status of the job in the jobs section. For that, and go to jobs, and in the configure tab you see the current status, and you need to refresh from time to time to see the status of the job. And after a short time the job is finished and we can continue in the flow creator. Let's establish a data subscription. For that we start again with an inject node to trigger the flow. Then we select the databus consumer, which is used to receive messages from the databus. We connect both of them, and afterwards we need a JSON node because the output of the databus consumer is usually a string and we want to work with objects. Then we insert two debug nodes. One is used for the message output and the other one for the databus return code. So we change the name of the debug node so that we know what we actually display. After that, we need to do some changes on the databus consumer because currently it's configured to receive the SINUMERIK high frequency data. We need to change the message name property to the property in the configuration, which was program status changed. So we get a notification whenever this variable changes. Then we connect the JSON node to the debug node, and we can deploy the flow and inject to start the flow. So now we receive a notification whenever we change the program status. So feel free to start or stop the program. Then you will get a message whenever you did that. And the message is usually made up of a header and a body. And the information is stored in the body. And there we can open it and we will see all of the data points that changed. And there we have the program status, and in the content array you will find the new value of this variable. And as you can see, at the moment it's 2, and the next time we see that the variable changed to 3. The program status from the data package. For that we use a change node. The change node is usually used to change the properties of a message object. We use it to pass the program status from the message. And the next step will be that we select the message and go through the structure of the databus message in order to parse the value of the program status variable. So we go on by typing in body. The next point is data point, and this is an array, so we select the first element. Then we go to the content array and select the first element again, and the same goes for the value array. And now we should be able to receive the variable, So we changed the name of the debug node to program status because we only received the parsed program status from the package. Deploy the changes, and after the deploy we switch the program status again by starting and stopping the program. But now we see that nothing changed. And the reason for that is that I forgot to change the payload property in the change node. So we add the payload property which contains this data package and confirm our changes by clicking done. And then we deploy the flow. And if we change the program status now, we should see only the number of the program status variable. So now everything is ready. Okay, the next step is to use the program status to set and reset a user alert. For that we use first of all link elements. Link elements are virtual connections between multiple lines of flow. It helps for a better overview. So we take a link out element and a link in element and connect both of them, and each message will be passed through the virtual connection. Next up, we take a switch node. The switch node is used to route messages according to a rule. In our case, we want to check whether the program is active and running. And for that, we take the program status, and when the program status is 3, the program is running. So the first rule is to check whether whenever the variable is not 3, we want to pass the message to the second output. So we put in the second rule and we change the expression, and after that we confirm by clicking done. Now we have a switch node with 2 outputs. The first output is to reset the user alert, so we take a change node and we call it reset user alert, and this is triggered whenever the program is running, because then we want to reset the user alert, so we set the message payload property to the value 0. The second change node is used to set the user alert. So whenever the program is interrupted or stopped, we want to set the user alert, and for that we set the message payload property to the value 1. After that, we confirm the changes and we insert a template node. The template node is usually used to create a message and to use a message property from the message that was passed to the template node. So in our case, we want to pass the payload property, which contains the value of the user alert, and we create the input for the parameter service writer node. And for that, highlighting. First of all, we copy the input template from the documentation, and we delete the second variable because we only need one variable, and we change the variable name to the PLC variable, which was db2.dbx 185.4, and the variable type is bool, so we change the variable type to 1, and the variable value is the message payload that is passed to the template node. Then we confirm the changes, and in the next step we insert a parameter service writer node. Then we connect the output of the input template, and the next step is to insert 2 debug nodes. The debug nodes are used to display the return code of the parameter service and the error message. So whenever an error occurs, it will be displayed by the debug node. Then we change the names of the debug nodes to have a better understanding of what the flow is actually doing. Okay, let's check if the flow is working. We click deploy, and now please start and stop the program. And we see, oh, there's something wrong because we have an error. And it is quite a common error because the parameter service requires an object as an input, but we passed a plain text, so a string. We need to change the output of the template to a parsed JSON in order to solve the error. Now we deploy the flow and we test it again. Now we can see that the parameter service error message shows that the return code is 0. The last step is to configure the user alerts, and for that we go to the SINUMERIK Operate, go to the user alerts, and for that we go to the SINUMERIK Operate, go to the Setup tab, click on HMI, and on the right side you will find the alarm texts, and there you select the manufacturer alarm text, and now we add a new user alert with the number 700,044. Because we can already see that this alarm is active, and now we only need to provide the alarm text, which is program execution stop, because the alarm should pop up whenever the program is not running. We confirm the change, and to save the user alarm text we need to do an HMI reset. After the HMI reboot, the user alert is already active, and now let's start the program, and we see that the user alert is gone. as long as the program is active. If we stop the program, you can see the user alert pops up again. So that was the second tutorial. In this tutorial, you learned how to work with SINUMERIK low-frequency data, so simple polling operations for reading and writing variables. Also, we talked about how to work with data subscriptions and how to set user alerts on the NCU. The next tutorial will be very special because we will work with high-frequency data coming from the SINUMERIK, and after that you will be able to calculate a floating average over a signal to a dashboard.